Let's continue to learn formation of trilaminar embryonic disc. The formation of trilaminar embryonic disc and its structure. Formation of the primitive streak. At the beginning of the third week, part of the cells in the epiblast proliferated rapidly and migrated to the midline of one end of the embryonic disc, forming a longitudinal cell column on the central axis, which is called primitive streak. The significance of primitive streak is to identify the embryo's middle axis, cranial and caudal ends, dorsal and ventral surfaces, right and left sides. The cranial end of the primitive streak is slightly expanded, which is the primitive node. In this slide, you can see primitive streak. Then, a shallow groove appears in the middle line of the primitive streak, and a shallow concave appears in the center of the primitive node, which is called primitive groove and primitive pin respectively. The appearance of the primitive streak makes the embryonic disc divided into head and tail, and the end where the primitive streak is located is the tail. Because the cranial end is larger and the caudal end is small, the embryonic disc is pear-shaped at this stage. Formation of the mesoderm. The cells in the deep part of the primitive groove proliferated continuously and expanded, migrated to the periphery between the epiblast and the hypoblast. A part of cells form an interlayer between the epiblast and the hypoblast, which is called intraembryonic mesoderm or mesoderm. It connects with the extraembryonic mesoderm at the edge of the embryonic disc. Another part of the cells enter the hypoblast and gradually replace all the cells in the hypoblast, forming a new layer of cells called endoderm. After the appearance of endoderm and mesoderm, the epiblast is called ectoderm. Therefore, at the end of the third week, the trilaminar embryonic disc is formed, and all of them originated from the epiblast. Two regions have no mesoderm: oropharyngeal membrane and cloacal membrane. This picture shows you two regions have no mesoderm: oropharyngeal membrane and cloacal membrane. And you can see primitive streak, primitive node. The arrows indicate the directions that cells migrating from primitive groove. Okay, let's see the formation of trilaminar embryonic disc from the surface view and cross-section. The left picture is surface view, which removed amniotic sac, and the right picture is cross-section. Between the blue and the yellow layers are the migrating cells, which finally form the endoderm. This picture is a cross-section of embryonic disc, and the red arrow points to the primitive groove, and the black arrows are the direction of migrating cells from primitive streak to the space between the epiblast and the hypoblast. In this slide, we can see the primitive streak, the directions of migrating cells, and the trilaminar embryonic disc, ectoderm, mesoderm, and endoderm. All of them originated from the epiblast. Trilaminar embryonic disc includes ectoderm, mesoderm, and endoderm. All of them originated from epiblast. The cells proliferating and migrating from the primitive pit to the cranial end form a single mesodermal cell cord between the endoderm and the ectoderm, called the node cord, which plays a certain role as a scaffold in the early embryo. The functions of the node cord are: it defines the primordial longitudinal axis of the embryo, and it gives it some rigidity. It provides signals that are necessary for the development of axial musculoskeletal structure and the central nervous system. It contributes to the intervertebral discs. This picture shows you the location of a node cord, and there is a small area without mesoderm on the head side of the node cord, and the tail side of the primitive streak where the endoderm and the ectoderm are attached in the form of membrane, which are called oropharyngeal membrane and cloacal membrane. With the development of embryonic body, the node cord grows and grows towards the cranial end, and the primitive streak is relatively shortened and finally disappears. Normally, the primitive streak undergoes degenerative changes and disappears by the end of the 4th week. In the future, if the cells of primitive streak remains, it can proliferate and differentiate to form teratoma composed of various tissues in the sacrococcygeal region. From top view, this animation shows the formation of primitive streak, primitive node, node cord, mesoderm, and formation process of trilaminar embryonic disc. From the perspective of cross-section, this animation shows the directions of migrating cells from primitive streak.